Hi again. In this one we will discuss the building envelope and how the building envelope and the choosing of this envelope material plays a significant role in the energy efficiency of the building. By building envelope we mean, of course, the walls, the roof, and even the floor at the foundation of the building that are in contact with the exterior elements. So the walls and the roof with the contact with the exterior air, and the foundation, of course, in contact with the soil. So this building envelope is basically the barrier between the interior and the exterior of the building, which helps us to maintain our main goal, which is conservation of the interior comfort temperature. As we explained earlier, the energy transfers through different ways, and the most important way in the buildings is the conduction, the heat transfer through the envelope solid material. So this is why when we take good care of our building envelope, we can achieve better energy conservation in the inside and limit our heat loss of the building. When we are in the design phase of the building envelope, the most important thing that we should consider is the material, the appropriate material choosing of the building. For example, materials such as concrete, brick, and stone have high thermal mass, which means that they store and release the heat slowly. So this feature of these materials helps us to regulate the temperature in the interior and limit and reduce the need for mechanical heating and cooling. On the other hand, materials like glass have low thermal mass, which means the building with large amount of glass facades or curtain walls may require additional insulation or shading devices and will use more mechanical heating and cooling. The other thing that we should take care of is the insulation materials. So insulation materials are the materials that have more resistance to this heat flow through them, and these materials are usually made of a variety of materials such as fiberglass, cellulose, and foam. And the effectiveness of these materials are usually measured with U value, so which leads us to the definition of U value. So what is U value? U value represents the rate that the heat flows through materials. So a low U value means that the material is a good insulator and the material reduces the amount of heat that transfers or passes through it. For example, here are some U values of insulation materials, and of course when we see them, they have, of course, lower values when we compare them to normal building materials such as brick or concrete or others. So when we want to make our building an energy efficient building and a building that conserves energy better and does not lose a lot of energy in between the interior and the exteriors, insulation materials are a critical issue. With that said, we can proceed now to the calculation of heat transfer in a building. So how can we calculate and analyze and predict how much energy this building will be using in a period of time for example, to heat or cool and maintain a good comfort temperature? This calculation is called the conduction heat loss. So as a definition, conduction heat loss refers to the transfer of heat through a material from a warmer area to a colder area. The rate of conduction heat loss is influenced by the thermal conductivity of the material and the thickness of the material. So to calculate the conduction heat loss, we use this formula where Q is the heat loss in watts, K is the thermal conductivity of the material, and A is the surface area of the material in square meters, and delta T is the difference of the temperature on each side of the material, and D is the thickness of the material. So let's put that in an example. Let's say that we have a wall made of concrete with thermal conductivity value of 1.5 and a surface area, like the wall surface area is 20 square meters, The temperature difference across the wall is 10 Kelvin. So if it's 60 outside, we can say it's like 70 inside or so. And the thickness of the wall to be 20 centimeters, which can be represented as 0.2 meters. So when we plug in these values, we get a total conduction heat loss of 150 watts. So this means the amount of heat that is transferred from from one side of this wall to the other side of this wall will be 150 watts per hour. Which means, of course, looking at the equation, if we want to reduce this heat transfer, we should reduce the amount of U value, which is using more insulation materials. So these values, of course, will make more sense in the next chapters when we talk about the energy performance of the building and we look at the practical example. And as a conclusion, if we use the appropriate building materials with the appropriate isolation materials with the right U values, we can limit the heat transfer or the heat loss from our building, which of course saves us more energy, and we can keep a comfortable ambience for the occupants.